Alright, I believe I'm streaming. Oh, sorry, recording. So I believe we're on day 14. 2 weeks in a row. Yeah, just not really going really long these days. Yeah, yesterday I did an hour, but wish I can do longer. Hopefully tomorrow I can do a little bit longer, but yeah, so today I believe I want to learn merge sort. So there's a couple things I gotta do to learn merge sort, and then we'll see what we can do after. So yeah, let me share my screen. So we'll just do this. Oh, by the way, thank you guys for the support, whoever's liking the videos, commenting, and doing all that type of stuff. I know we had a couple comments there. Yep, appreciate the support, man. Anyways, let's learn merge sort. So merge sort is a recursive sorting algorithm that's quite a bit faster than bubble sort. It's a divide and conquer algorithm. So recursion occurs when okay. Explain recursion and divide and conquer algorithm in easier words. Just trying to understand what's going on. Recursion is when a function calls itself to solve a smaller version of the same problem. Think of it like this: if n equals 0, print done, else print n, and count down. Okay, so this prints 5, 4, 3, 2, 1. That adds 1 to the whatever. Divide and conquer any. Wait, what? Think about it. You're standing on stairs and you ask the person below you to count the rest of the stairs for you. Each person keeps asking the. You can see that cricket? I'm so sorry. Below you count the rest of the stairs for you. Each person keeps asking the next until is at the last. Each person keeps asking the next until someone is at the last stair and says 1. Then everyone adds 1 on their way back up. Okay. Divide and conquer in easier words. Divide and conquer means split a big problem, solve, combine. Yeah, like binary search. Yep. Okay, cool. Divide the large problem into small pieces and recursively solve the smaller problems. Conquer, combine the result of the smaller problems to solve the large problem. So in merge sort, we divide the array into 2 equal halves. Divide. Recursively sort the 2 halves. So merge the 2 halves to form a sorted array. Conquer. Alright, let's watch this video. My headphones are... Where the hell are my headphones? I think they're over there. Give me 1 second. Okay. Just give me 1 second, guys. I'm a mess. Holy shoot. Come on. Ow. Okay. Kinda hot in here. Okay. Let's watch this video together and then we'll move on. Cool. Okay. Okay. Let's watch this.
First, let me explain the pros and cons of merge sort, and then we'll break down the algorithm step by step. Merge sort is much more efficient than bubble sort, which if you're here slogging through an algorithms course, you probably already know a little bit about. In big O terms, merge sort is order n log n, which makes it a lot faster than bubble sort's shameful order n squared. Now, order n log n is about as good as we can do when it comes to sorting unsorted lists. But there are a lot of things that affect performance on a smaller scale that are worth thinking about. For example, merge sort's space complexity is less than ideal. It requires copies of the original list to work with, which means it's going to take up more memory than an algorithm that can sort the list in place. It's also slower than some other algorithms like insertion sort when it comes to sorting smaller lists. And that's because of the memory allocation, the copying, and even the overhead of the recursive function calls. All those things have a constant toll on the performance of the algorithm. So they don't really affect the big O, which is order n log n, but they do affect the performance in practice. And that effect is disproportionately bad on smaller lists. Okay, so how does merge sort work? Well, first we start with an unsorted list of numbers. We split the list into two parts, and we keep doing that recursively until each list has at most one item. Next, we start merging each of those lists back together. The process is actually pretty simple. We take two small lists, iterate over each item in both lists at the same time from left to right, and we just compare them, moving the smaller of the two into a newly sorted list. By the time we've moved all the way back up the tree, you'll have a fully sorted single list. It's a recursive divide and conquer algorithm. It uses a pair of recursive calls at each level to split the list into parts, all the way down until we have a single element in each list. Then it merges them all back up the call stack again by looking at each element in both of the lists one at a time. It's an n log n algorithm because it needs to be called recursively log n times. And at each level in the recursive call, all items in the list are compared.
I think I get it. Okay, I guess we're doing this right here. So algorithm. The algorithm consists of two separate functions, merge sort and merge. Merge sort divides the input array into two halves, calls itself on each half, and then merges two sorted half back together in order. The merge function merges two already sorted lists back into a single sorted list at the lowest level recursion. The two sorted lists will have one element. The two sorted list. So, what I see is that merge sort. So it divides the input array into two halves. So 1, 2, 3, 4, 5, 6. It goes to 1 to 3, 4 to 6. Then calls itself on each half. Then merges the two sorted halves back together in order. Two arrays. Wait, and then merges the two sorted arrays. What the fuck? So literally, they split the list. Do bubbles? What the hell? Merges two already sorted lists back into a single list at the lowest level recursion. The two sorted lists will the two sorted lists only have one element. Those single element lists will be merged into a sorted list of the length 2, and we could build from there. In other words, all the real sorting happens in the merge function. Merge sort pseudocode. So input A, an unsorted list of integers, which is nums. So if the length of A is less than 2, it's already sorted, so return it. So we know if nums is less than length 2, return what? Sorry, so return nums. Right. Now I understand why it's less than 2, because if it's just less than 2, it should already be sorted as 1. It might be 1 here. No, it's 2. It has to be 2. Split the input array into two halves down the middle. Split the input array in 2 halves down the middle. Okay. So split is equal to the len of nums so this is where I like to test stuff here. This is where I like to test stuff. So let's just say nums is equal to a list of 1, 2, 3, 4, 5, 6. And I need to do x is equal to, no, let's just do what we're doing. Split. Oh, damn, I can't type. Split is len of nums divided by 2. No. Oh, sorry. Split. Fuck, no. Fuck, how do we do this? Split first half sorry, oh, son of a gun. So I do 4 num in range of 0 to nums. Split first half the append no if no yeah I gotta do if num what do you mean 0 if num is less than fuck, this doesn't work. This is what I was trying to do. Fuck me. Dang, that's cool. Mid. Never knew that. Oh, never mind. I thought mid was just like an actual like a I don't know, something that helps you like get halfway. I'm tripping. I thought this was the second thing. This is what I was trying to do. What does this do? What does that do? That gave me 3 last time. So my idea in the beginning. What the fuck? So first half is equal to nums 3 nums split. No, that's wrong. That would be the first one. If I do split, first half 1 2 3. Second half is equal to nums split. Bro, how did that not? Huh? What the hell is weird? I feel like there's another way. If I do, and the nums is up there, so if I do 4, like I did before, num and range, for num and range, like I did before, nums, that's, oh, so if I do nums, if I do nums, this is just gonna print, hold on. If I do 0 to nums, this is just gonna print to 5, because the nums is not, watch this, 1 to 5, wait, what? Oh. What? Oh, do I just need to do this? What am I doing 0 for? It's taking 5. So nums plus 1. Bro, do I even need to put that? I'm tripping, bro. 6, you dumbass. I'm tripping, bro. 96. I got the 6. So now... Oh, that's why I did the range, because I need the indexes. I need the flipping indexes. It's like, why was I doing range? But I understand why I was doing range. I need the indexes. How should I do this, bro? This never worked on range to 0. I know this is, I'm doing too much, but I'm learning. Like, I'm just like messing around, you know what I mean? Like, I gotta understand this. Nums. If I do that, what? Oh my god, sorry, I did not print num. Give me this integer, right? Wait, what? So I do that like I did before. It'll give me 1 to 5. If I do plus 1 on the outside of the line, 6. There it is, mother flipper. I think I put it in the nums. So if I do that, so first half, okay, I need to, I'm gonna just do this right here real quick. So first half is equal to no. If num 0 just not greater. No. If the index, so if this index if num is not greater than half is equal to the len of nums. Half is yeah. So now then we'll just do if the nums if num is num oh sorry, I meant first. But we'll keep that though. If num is less than, sorry, if this is less than half. No, it's greater than. If num is num, so that say it's like it's 3, so that it's out of range. Okay. Hold on. What if I do print nums? No. 4. Yeah, I'll get 1. I'll be 1. 1. It's not. If 1 is greater than, no. If 1 is less than or equal to that, and then we print the first half. That's, I don't understand. Did I click anything? No. You're looping one index too far. Oh, so I guess this was, I don't need this. Oh my god. Why would I put +1? 0 to 5 is 6 numbers. Ah, my god, that pisses me off so easy. I gotta remember that, man. Fuck. Second half. Append. Notice. No. Oh, sorry. Print. Second half. Yeah, you're right. That's not 3. Damn. I guess we're doing this way. Fuck. That's barely the second step. Whatever. Let's see if I remember. So the way we split it is if we want the half, it's gonna equal to the length of nums by 2. If say the length of nums is 8, that'll be 4, and that'll be the half. Alright, and then now we want the first half. So first half is equal to nums anything before the half, and then second half is equal to nums anything before the half. Okay. Oh, I already had that. That's wrong. Anyways. Okay. Call merge sort twice. Once on each half. What? Call it twice. Call merge sort. Call merge sort twice. Once on each half. Call merge sort twice on each half. So 1 2 3 1 2 3, then 4 5 6 4 5 6, like twice like that. I think it's I think I know how to do it. I'm just a little stuck on what it means. Like, wait, what? You better not tell me fucking like something on Mercer. Yeah. Problem in this line. This is trying to compare list nums to a number which will give you an error. If nums is less than after you fix that, once the base case is working, move it. You already split the list into first step. No, hit for step 3. You need to recursively call Mercer on HF. So what? If length? Wait, what did I do? It's saying that's a problem? If numbers is less than oh, if the length, so damn. If the I fucked that up. If the length of nums, if the length of nums is less than 2, fuck. Sorry. After you fix that, once the base case is working, move to step 3. You already split that now, so you need to recursively call Mercer on HF. So what happens if you do left sorted, right sorted? What should you pass to Mercer, and what should you store it as? What? So what happens if you do left sorted, right sorted? What should you pass into merge sort, and what should you store it as? So okay, so you need to recursively call merge sort on each half. Left sorted. This is not even already sorted. So I have the fucking first half. I gotta sort that, then go to the second half. Right? Call merge sort twice. You need to recursively go. So what happens if you do left sorted? Right sorted. Once both halves are sorted, step 4 is to return the result of merge. Don't forget, merge is where the real sorting happens. Oh, I see. You need to recursively merge sort on each half. So what happens if you... Alright, when I call merge sort on each half, do I each have, this is the 5291. First half is 52. Now left sort is merge sort first half. Right sort second half. I get it. 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 Merge first half is equal to merge oh, there's too much merges and merge. I like how you did it. Left side sorted first, no, sorry, right side sorted, just merge, sorry, merge, sorted, yeah, merge, gotta call it. So now this is where all the sorting happens. I get what it's calling. I get it. Then at the end, we need to return left side sorted plus right side sorted. I got it. I get it. Okay. I get it. What? E-commerce ownership, the line. This just concatenates two sorted halves. It doesn't really merge them in sorted order. So instead of plus, you want to call your merge function. That way you're telling the problem. That way you're telling your problem, now that I've got two sorted halves, please merge them properly into one sorted list. Okay. Alright, then for merged. So this is where the fuckery happens. So we create a new okay, inputs A and B, two sorted lists of integers. So we create a new final list of integers. Create a new final list of integers. What the fuck? Create a new final list of integers. So set I and j equal to 0. Oh, okay. So I 0 j equals to 0. Use a loop to compare the current elements of A and B. If an element in A is less than or equal to the respective elements in B, add it to the final list. I get what it means. Final. It's just a list. So we do for we want to check to compare the correct elements of A and B. Then we use to keep track. There's a final list. Otherwise, add the item in B to the final list. To the final list and increment j. Continue until all on. So for use a loop to compare the current elements of A. So for index and range len use a loop to compare the current elements of A and B. Then we use, so we create a new final list of integers, right? Now we set I and j equal to 0. They will be used to keep track of indexes in the input list of A and B. Whoa. The hell was that? This is loading the whole time, bro. What's up with this? For merge, you have two sorted lists, first and second. You need to build one final sorted from it by comparing elements one by one from the first and second. Single step. Use I to track your position in first, and J to track your. So for index in first, for index in second, compare first I if index 0, no, if first index is greater than second index, we want to do, oh, did that give me a good indentation? Okay, yeah, I plus equal 1, else j is plus equal 1. Whoa. There may be some items left over in A or B. Add those extra lines to finalize. What the fuck? Whatever. First index is less than second index. We want to do j plus equals 1, else append leftover to final. And then return final. I think that's how you do it. Bro, what is up with this shit, bro? Is it my mouse? Holy shit. But that means you're comparing every element in first to every element in second, which is not what merge wants. Instead of using, yeah, you're right. Instead of for index in, use a while loop that runs as long as all the indexes, no. A while loop that runs as long as I and j are within range. I don't know, within range. That's within range. You're right. This is gone. I gotta restart. Actually, just keep it. Wow. Wow. J is no. Well, I is greater than the. Well, I is greater than the length of first. Right, if I is greater than the length, no, it's less than. Oh yeah, because if it runs out the length, if length is, yeah, okay. And, yeah, J is less than the length of seconds. Length of seconds. What we want to do to compare the current elements of A and B. If A is less than or equal to, if A is less than well, if first I and we'll do first final append first I less than or equal greater than, sorry, if A is less than or equal to the less than or equal to its respective elements of B, add to the final lesser increment. Otherwise, add B to the final. Okay. First is greater than or equal to J.I. We want to do this. Bro, why does it always do that, bro? Final append. This is a whole bunch of junk. Second J else. I'm not sure how to append if it's over. Fuck. Whoa, holy shit, I didn't mean to do that. Yeah, that deletes the whole line? Nice. I didn't know that. Fuck. That, okay, I get that. One of the list my sub items. The rest of the elements. I don't know how to do that. before I even ask it to do it for me, let me try to see if I can do it on my own. Nothing else. So can I just do final dot append? No, I can't. That's just gonna append the whole thing after. I don't know. Alright, I get that. So 5 is left. Now J is out of bounds. First. As the loop runs, you compare and add 1 to 2. Add 1. 3 to 2. Then you do 5 to 2. No, sorry. 3 to 4. Then you have 5. 5 to 4, add 4. Now you just need 5. Oh, okay. So I do if len of first equals to 0, we're just gonna do final append J. Else final append for first I. If this is, then that's done. No. If first it was unknown if not just add, you already have this, not just add after that append everything from first I to final. You can use a loop or a slice to do this. Equals first I gives you the rest of the first. Starting from I. So if I don't know how to do it, bro. Well, I is less than the length of first, and J is less than. Well, I is less than the length for. Bro. I have to do another while loop. So this is what I did before. I is less than. Well, I is less than the length of. So if first. Bro, what the fuck is going on, bro? Yeah, man, this was a hard one. This was a hard one, man. I took it out, bro. I would love to see what he did. So if len now is less to return. Okay, now this left sort side merge sort. Damn, so he put this motherfucker inside. So merge sort nuns, and then this on the left side. Damn, so you don't even need the half thing. He put that motherfucker inside. That's fire. Okay, now let's look at this side. So final ij. So while I is less than length of first. Okay, we append else, append j. We really didn't, I didn't need elf. I could just put else. And then everything on the bottom is the same. So I is less. Damn, bro. I don't know about y'all, but that was OD, man. That was hard, bro. Merge sort implementation reference. So everything we just did. What is a merge sort's big O complexity? Oh, what? Merge sort. It's not n squared. It's not constant. Sorry. Why merge sort? Merge sort is much faster than bubble sort. O and log n instead of on stable. Use on balance. When might merge sort be a good idea? Well, memories. Yeah, memory's gonna be an issue. If you know which function is recursive, merge sort or merge. And it calls itself here. This is where I'm tripping. Merge sort, yeah. The fuck? How do I click merge? Oh man. Fuck. Simple. Okay, so tomorrow I think I'm gonna solve these LeetCode problems, merge sort, and another bubble sort. So 2 LeetCode problems tomorrow. So I can solidify me understanding merge sort and bubble sort before I keep moving on in the data structures thing. So I think today I'll call it. It's kind of hard. A lot of thinking. I messed up a lot. But yeah, sorry for just seeing me not my fullest capability, but thank you guys for watching. It means a lot to me, and yeah, see you guys tomorrow.